This is Autoline This Week, the show that gets you inside the global automotive industry. Autoline This Week partnered with the Consulate General of Canada in Detroit to produce this episode.
Hi, I'm John McElroy, and thanks for joining us on Autoline This Week. As you all know, the automotive industry is under pressure to really clean up its cars. That's why we're seeing such a big move into electrification. That's not what today's talk is about. It's other ways of making cars more environmentally friendly and sustainable. We're going to be talking about manufacturing cars with biomaterials. And joining me for today's discussion are Dr. Mohini Sain. He's the director of the Center for Biocomposites and Biomaterials Processing at the University of Toronto. And Dr. Hamdy Khalil is the Global Senior Technical Director for Research and Development at Woodbridge, the supplier. And I want to thank you both for joining me today.
Thank you.
Thank you.
So, Dr. Sain, let me start with you. And just to get the conversation going, you deal with biocomposites and biomaterials. What the heck are biomaterials?
Well, basically, they are derived from forest or agricultural resources. So they are, you can generate the crops within a time period, which is either annually or within 10 or 20 years time period if it is a forest. So naturally, this is sustainable resource and it has a minimum sort of an effect on the environment and also on the effects of water and air. So that's why it is a sustainable raw material to start with.
Oh, and I want to get into more details of what kinds of bio plants are ideal for that. But Dr. Khalil, Woodbridge, very famous for all the foam that it makes, largely goes into seating and other parts of the car. But same thing, are you able to use biofoam?
First of all, thank you for the invitation, and it's a good opportunity to participate in this exciting session. I just want to make one correction. When we say biofoam, actually the foam contains biomaterial. Biofoam implies that the main material is biomaterial, which is not the case. The biomaterial that we are using is used as an additive, as a certain percentage of the foam itself. And we have, as a company, actually pioneered the inclusion of biomaterials as defined by Dr. Sain into the manufacturing of the interior parts for the automotive industry. We introduced this material in 1995 prior to it becoming fashionable. And we have successfully by now millions and millions of cars on the highway and the speedways of both Canada and United States and globally that contains certain percentage of renewable, sustainable material. It's not just renewable, but it's also sustainable materials.
Mm-hmm. Dr. Sain, is it fashionable now? How much interest is there on the part of the automotive industry for biomaterials?
Well, I tell you, irrespective of the OEMs, whether it is Ford or General Motors, I think overall there's a global awareness in the last 5 years because of the climate change. We have a climate change protocol that's ratified in Paris. Everybody looking at how to comply to the rules and regulations of the emissions. So therefore, having this renewable carbon in car as much as possible is not only become a fashion, but also it's become a reality of giving these automotive industries some sort of tool to reduce the emission and also use it as a carbon storage and get the credit for that. So it has two springs. One is the credit they can get as a renewable carbon material, and at the same time, it is green. Which has definitely a perception out there that it's good, and it's social good, it's economic good, and environmental good.
Dr. Khalil, you say 1995 you first came out with this material.
Yes.
What took so long for it to catch on? Was it cost? Was it doubts whether the material would be durable enough for automotive applications, or why did it take so long?
Well, I would say it's acceptance. The automotive industry although very, very progressive and one of the most advanced technologically, but they are very conservative. When they introduce new material, it takes a very long time to qualify, and it requires more data and working with the OEMs firsthand until they feel comfortable that you eliminate the myth of using, for example, natural resource into automotive seating, because the level of know-how and the level of awareness is not as high as on our side, where we have invested significant amount of time harnessing the renewable material and making products that can be introduced without sacrificing the performance. This is very important, because it is not a matter of introducing biomaterial, but to introduce the biomaterial and maintain meeting the specifications, which is very, very rigid when it comes to the automotive industry, as it relates to safety, as it relates to durability, as it relates to every aspect. I just want to add to what Professor Mohini said, that it is now desirable by all OEMs to have renewable content in their products, and they strive to increase this percentage of renewable content in the product, let it be a composite or individual products or the likes. But one has to emphasize that nobody, and I mean nobody, will pay for green or sustainable or renewable. So it becomes the challenge of people like ourselves, manufacturer of parts, and the academician like Dr. Mohini, to find ways by which we can create these materials, extract them economically, and introduce them without increasing the cost. That's very, very important. Very important to be understood. And we, in our world, accepted that challenge from the OEMs. So they put the ball in our court to provide the renewable content over the last few years.
So where do you stand from a cost standpoint now? Are you competitive with petroleum-based materials?
We are competitive with petroleum-based materials, and sometimes we are either at par with it, or we create advantages that cannot be obtained by the petroleum material that the customer is willing to pay for. If we can introduce a new property or modify a new property or solve chronic problems by using renewable materials. And that's very, very, very important for us.
Dr. Sain, oh, sorry, go ahead.
Yeah, I want to add to that, where the technology is moving. We are working with Ford, and the leadership of Dr. Jimmy Young and Farouk and Virat. So what we are seeing that if you bring more functionality in a single part system, so you can get more cost effectiveness. So you can sell a product at the same time. It's not only lightweight. If it is a good NVH, that means it's a noise and other type of heat resistance property, which this renewable bringing in as an additional feature, which a fiberglass or other metal cannot do. So that those features being an inherent part of the selling point, and their cost competition become now is not orange to orange, but it has a functionality which gives you more value, bringing in renewable. So renewable has this uniqueness, which we are really nurturing and bringing to the marketplace from the technology standpoint.
Yeah, and this functionality has to provide an advantage to the OEMs. So obviously the OEMs would like to have not only to advertise and be proud of introducing renewable content and green products and addressing the greenhouse effect and all of this, but also we have that advantage by including the the renewable green materials, and let it be a function that did not exist or a function that has been enhanced significantly, like comfort, for example, like NVH, as Dr. Mohini mentioned. Any of these is very important to highlight as a side effect.
So, Dr. Sain, give us some examples, and I think you've got some components there too. What are the best applications for these biocomposites and biomaterials?
I will show you one. For example, this is a engine beauty cover, as you can see here, right? So this is actually made from fiberglass in normal way, but here we did not use any fiberglass. We use microfiber from the forest resources, and it allows two things. One is it reduces the weight, it increases the green carbon content inside, and also it allows much more noise and vibration resistance. For example, normally you will have this with a foam. You can see that?
Yeah.
Now, this particular material you can use without even foaming application in that. So inbuilt, it can give you a property which will allow you to get less vibration and noise when you are using for engine cover, engine beauty cover, for example. That's a classical example.
That's a pretty good example, what you're using right there, because it's a large part, it's under the hood, so it's got to stand up to high temperatures too. That tells me these biomaterials are pretty strong.
Yeah, so what happened is you have to have a technology here too. It's not too easy to make a biomaterial which is very susceptible to temperature, not to be susceptible to high temperature. So the technology here, how you can interact with this biomaterial, biofiber, and your plastic, so that the interface becomes different in terms of their crystallinity, their nature, and increase the temperature resistance. So the key here is the technology at the interface, and that will change the heat resistance properties of this material. So this kind of technology is now available in the marketplace.
Yeah. And Dr. Khalil, I believe you've got some examples too of seating foam that uses these biomaterials.
Yeah, this is an automotive seat cushion. That's for a driver's seat that contains various regions. This is for the thigh. Here is the butt, and here's the back. And each area has specifications to meet and certain properties. And we include materials either derived from plants or derived from lignocellulosic materials from wood in order to create this brand of green light that Woodbridge has developed over the years. And each region contains certain percentage of renewable and sustainable material to end up with about between 10 to 15% of the total cushion made that contains 15% of renewable materials. And
so I'm guessing there that the different segments of that foam for the seat has different density.
Absolutely.
Right under your butt, you want firmer density, and out by your thighs, you want softer.
That's the side. What is the softest? And here is the hardest. So that's.
So that's pretty sophisticated that you can come up with different densities with the same molding in different places with these biomaterials.
This is very, very important point. And that takes me to, you are not only developing materials that contains green and sustainable materials, you are also developing a process, because this is put in a mold. And in order for us to have here soft and here is harder and here is more harder, it has to be coupled with a process that is robotically controlled in order to pour in the mold itself certain formulation for this, another formulation for that, another formulation for that, another formulation on the sides, and those two are not the same. And that is done on a moving line. So the sophistication of the technology allows us really to engineer a cushion of that nature. And that's so, to drive the point, it is not just good to have renewable, sustainable material, but also a process by which you can introduce these materials in the system itself. And we are, as a company, very, very fortunate to be surrounded by significant number of universities in Canada that we can harness the students that will come out from Canada and use them as a co-op students and develop them internally in order to really engrave in their brains what is it that we're trying to do. And the government support us in that, and the Canadian government support us in that, and that's why we have, R&D established here in Toronto that has many of the Canadian talents that's graduated from about 14 universities around Woodbridge. So you have plant, and you have lignocellulose. Now there are concern. For example, in Asia, they say don't use plant because that interfere with the food chain, Asia and Europe. While in North America, we have surplus of these materials, so we can use it. So we have to adapt the technology in order to satisfy both the North American, the European, and the Asian countries, without really interfering with the food chain. And the benefit of having such a talent pool around us in Canada is really helping a great deal in that.
Go ahead, Dr. Sain.
Can I show another new technology which we are working with another company, Green Nano Composites, and it's a blue cam cover here. You can see that this is a hybrid technology. What we try to find here, it's maximum lightweighting at the same time bio content, which is in the nano level. So what we have done in this material, we have used very tiny cellulose from forest resources, which is known as nanocellulose, which are very hard to disperse. So very small amount of those nanocellulose being incorporated with recycled and reused carbon fiber. These are not actually very virgin carbon fiber. This is coming out from the other industries waste, and we combine them and hybridize them with a very unique technology. And now you can have this cam cover, which is very, very light. It's about 40% lighter than the conventional one. And it can also take the color. So we are working with Erin Gaynor, we are working with color companies, and also with food and our technology group to develop this kind of material for the next generation electrification technology as well. So you can see that as we move, how much development is technologically happening, and this transfer of technology of this kind of products going to the marketplace, not only for the conventional powertrain, but also electrified powertrain will be extremely important for lightweighting, for increasing the carbon content, and also allowing reduced greenhouse gas emissions. So those are different technology coming into the marketplace. And this is a very exciting time, not only for us, I think for consumers, for industry, and also for academia who are involved in this kind of research area.
That's a very sophisticated and complex molding right there. It would suggest that you could do almost anything. Or are there design constraints that designers and engineers have got to keep in mind when they're using these materials?
That's correct. So we are working, for example, a product we have, we're working with Erin Gaynor, which is a company. They sometimes find that a part which is sometimes it will be weak, in some cases. But you see that we allow design changes, fins in this case. So these fins allows us to have two different type of compositions so that we can justify the strength, performance, and functionality in this case. So So this kind of design is becoming very, very important. Sometimes we are doing hybrid design where we can have a organic sheets compared with the carbon fiber and then biofiber. So embedded in one single system. So these are the design criteria which are becoming very, very important. So it is not only the material, but I think more important is the design. How you can combine different in single part, different type of places, different components, and come up with a unique technology that will give the advantage, not only for the lightweightness, not only for the greenhouse gas emissions, but also functionality, which is very, very important. So these are the new and very transformative changes happening in the automotive and aerospace industry.
No, I love what you're talking about. You're hitting all the hot buttons. Make it better, make it lighter, make it cheaper. That's excellent.
Multifunctional.
Yeah.
Dr. Khalil, how recyclable is this, though? I mean, it's great to use these biomaterials, but what about at the end of life? Can they be easily recycled and brought back into the industrial stream?
Yeah, usually the recyclability technology is slightly behind the development technology. But with respect to recyclability with the foam that we make, we have been working on technologies for recycling the foam, I would say for the last 10 years or so. We're making some progress, and my expectations that it will come to light, which is very, very important within the next year or two. It's something that we are very, very conscious of in the big scheme of us trying to meet the United Nations sustainability development goals as part of our mission. And so recyclability is very important. On the other hand, there are products that have been already recycled and repurposed with the intent to provide ingredients that we can reintroduce in the product that we use. And that is also another avenue, not only through green and sustainable product, but the use of recyclable material and including recyclable content in the product that we make. I just wanted to complement what Dr. Sain said and show you an example of something like headliner. That's the headliner that you have on the top of your car when you're sitting there. That's the composite. It's a composite and sophisticated material. Currently, what is being used as reinforcing fiber is fiberglass. And fiberglass, in our opinion, it's the next worst thing after asbestos. So we are working with other producers of natural fibers, both in Europe and in Canada, as well as in the United States, to identify fibers that can be included in this structure as reinforcement in order to replace fiberglass. And that's a major undertaking we are pursuing in order to eliminate the use of fiberglass in these products. And we believe through the various fibers that Dr. Sain mentioned, we will be able to really make major success. And we are realistic, like if we can reduce 5% of fiberglass, 10% of fiberglass, 20% over a period of time, while maintaining the performance of the composite that we have, let it be a headliner or let it be any other composite, the progress is being made step by step in order to continue to maintain the specifications that we must meet, which is very, very important. Not only the specifications, but the cost, as well as the various performance material. There is another angle that's emerging, and we have been really leading this effort for the last 10 years or so, and that is the volatile organic compounds that's being emitted inside the cabinet of the car. This is a major, major undertaking and a major, major problem for all concerns, because every automotive industry has its own specifications, its own analytical techniques, its own way of analyzing the data, which creates significant problems for people like us as well as the academician. So what we have done, we put together a panel from major automotive manufacturers, major chemical suppliers like BASF, Dow, Huntsman, and Covestro, which is Bayer, and the producers like Woodbridge and Lear and others, to come up with what we call harmonized specifications in order to really put together specifications that we could meet without sacrificing the comfort as well as the safety of the passengers.
Yeah, and I'm afraid we're running down to the very end here. I'm going to have to cut you off there. I'm sorry.
That's okay.
But thank you for both of your insights into this use of biomaterials and biocomposites. Very interesting.
Thank you.
Autoline This Week partnered with the Consulate General of Canada in Detroit to produce this episode.